Hi everyone, and welcome to the following of Bonding Curve 2.sol. In this part we're going to continue with the functions of this smart contract, and finally we will deploy it and compile it and test it in the next parts. So the next function is for selling the tokens. So function sell tokens. So we'll get the uint 256 amount again. uint 256 amount, token amount. So it's a public and payable function. And so first of all, we'll determine the if amount again, right? So uint 256 if amount, which will equal to the calculate if amount, and it will get the token amount, and this time this is false. So you might have understood what is this boolean is. So whenever we wanted to buy, it was true. Now that we want to sell it, it's false. So it's a boolean parameter that determines whether we are buying or selling. So based on the fact that whether we are buying or selling, it will be true or false. So this is really important for calculating the if amount, which is the price, because here if we are buying, the total supply is going to increase, and so the price will be increasing. And once we sell the tokens, the price will decrease, the total supply will decrease, and so the price. So this is really important. So if it's true, the price should go up. If it's false, the price should go down. Also, the total supply should be. So we've added this to this smart contract, but in the previous one, it wouldn't matter. Why? Because at the time that we were determining the price at that specific moment was kind of a fixed price, right? And it would be fixed for any number of items that you wanted to buy, and it would change afterward you bought them or sold them, right? So we wouldn't need to decrease or increase the price every time we were buying or selling, because we would multiply or divide the number. So if you haven't understand what I'm saying right now, don't worry, because at the end of this smart contract you will understand it. Right now, because we haven't written the calculate if amount, you might not understand what I'm saying right now. Anyway, let's continue, and don't worry if you haven't got what I've said. So require that the balances of the message to the sender balances of, and as you can remember, this one was message.value. Here is the balances, because we're selling the tokens, so the number of tokens should be in a correct way. So balances of the msg.sender greater than or equal to the token amount, otherwise insufficient balances. So here we check the balance of the token, but when we wanted to buy, we would check the balance of the Ethereum, which is the currency that we want to buy the tokens with. So that's the require, and now we'll have the burn, and burn is a built-in function inside of the ERC20.sol of the OpenZeppelin. So burn payable msg.sender, and it will be the token amount. The second one of the burn function is the token amount. So we're going to burn these tokens because we're selling them, so that the total supply will decrease. So now in the end we will transfer the amount of Ethereum to the person, and also before that we should decrease the balance of the message.sender, msg.sender, so minus equal to the token amount, and then we'll have payable msg.sender dot transfer ETH amount. So that's it, and that's it for the self tokens function. So remember that whenever you want to transfer the money, which is Ethereum, you need to use payable. So I have said this in the previous tutorials, but I'm going to repeat this because this is really important. If you don't put the payable, then you will face the error. But you don't need to do this for transferring the tokens, but for Ethereum you need to do this. So for transferring the tokens, you just need to change the balances of that person, of that message.sender, of that address. But for Ethereum, that's a different story. So the next function that we're going to write here is finally calculate ETH amount. So calculate ETH amount. So we will get the token amount and the Boolean parameter, which is buying. So uint 256 token amount. So that's it, and the Boolean parameter bool buying. So this public returns uint 256. Public returns uint 256. It will return the ETH amount. So uint 256. So open the brackets, and it will get the price per token. So it will get the current price from the very same current price function that we had in the previous tutorial. So the job that it will do here was to calculate the price based on the total supply that we had. So we'll get the total supply and calculate the price. And you might say, why do we not enter the total supply? Because this is a public variable here. Actually, it's not a public variable, but it can also be a public variable, but it is known here, it is defined here. So we haven't defined it inside of this function so that we input the get current price. This is the kind of variable that is known in the entire contract. So first of all, notice that here we've set this to public so that we can also check the supply. Also, you can check the total supply because this is a built-in variable inside of the erc20.sol OpenZeppelin. But this supply right over here is the kind of variable that we have defined. We can just not define it and consider the total supply as a variable, but I've written this here for you to better understand what's going on and the fact that this is a variable. But if I had worked with the total supply, you might have confused it a little bit and you might not have understood that I've got it from this contract. Anyway, so function calculate ETH amount. So we'll get the uint 256 price per token, which will be equal to get current price function. It will have no input for this function. It will automatically calculate the ETH amount, the current price actually. So uint 256 ETH amount, right? ETH amount, and so by default we will set this to get current price. This is the initial value that we will give to the ETH amount, but it will increase or decrease based on the sells or buy. So ETH amount equals to price per token. This one is for the first token, right? So for the first token, price per token determines the first token ETH amount based on the get current price. But then for the rest of the coins, imagine that we're buying them, we need to get into the for loop, increase the total supply, and also calculate the current price based on the current total supply, right? So because the price changes based on the total supply, then one by one we check the tokens and we increase the price, and then we will add this to the ETH amount sum. So let's get into the for loop for you to better understand what we're doing. So we've got this for loop which will get the uint to 56i, uint to 56i. So it's actually equal to 0, and it will be I should be less than the token amount, because it starts from 0, less than the token amount, and then we'll have the I++. Here we go. So once we get in here, we check whether we're buying or selling. So if buying is true, then we will increase the total supply. So total supply plus equal 1. And else, if you're selling, we have the supply minus equal 1. And here we go, get out of the else. So the ETH amount plus equal the get current price Notice that even if we're selling, then because we want to determine the ETH amount, we will again actually increment the get current price based on that. So you might say that, okay, when we are selling, it should be minus plus get current price, but actually minus equal the get current price, but that is wrong, because you want to calculate the total number of tokens based on sales or buy. And when we are selling, the first token that you sell is, for example, X. The next token that you want to sell is X minus 1. So the price will be actually decreased. So anyway, so actually the X minus 1 is true when it is a linear pattern, but here our pattern is actually parabolic, so it's different. But anyway, the algorithm is the same. So if you think about the algorithm, you will understand what I mean. So the total supply increases if you're buying, and we'll get the current price, we'll calculate the ETH amount, and then it will serve the purpose of whether sell tokens or buy tokens. Anyway, in the end, it will return the ETH amount. And that's it for this function. So that's also it for this part of the tutorial. We will follow the with the only one function that has been remained, and also the compiling and deploying the smart contract in the next part. So until the next one, goodbye.